Okay. Now the next lecture is Colliods State in short discussion. Absorption is related to colloid. Okay. So when we study colloid, when we study absorption, we have to study detail about colloid. Okay. How the colloid form, what is the colloid. Okay. We have to study. Okay. Now the difference between true solution, colloid solution and suspension. So always remember, when in a solution there are some particles that should be added, they are completely miscible. If they are completely miscible, they are termed as true solution. Okay. But when they are not completely miscible, but they are not completely miscible, but they are uniform with the solution, that should be called colloidal solution. And suspension means there should be bigger particles, and that they are not miscible in the solution. Even if they are more and more added, they make the whole of the solution as a suspend type solution. Okay, that's suspension. There must be the difference between colloidal and suspension solution is nothing but colloidal solution, the particles are smaller than suspend particles. Okay, in suspension the particles having the size much larger. Okay, and colloidal solution never settle down, but suspension that should be settled. And colloidal solution can be able to scatter light, but suspension do not scatter any type of light. Okay, so we study detail the difference between the three types of solution, that is first one true solution, second one colloidal solution, and third one suspension solution, in the basis of the particle uniform distribution in the solution and their settle down properties. Okay. Okay, now consider true solution, that is particle size less than 10 angstrom 1 nanometer. Okay, 10 angstrom and 1 nanometer. Okay, 2 minutes. Okay, true solution means particle size less than 10 angstrom 1 nanometer. Colloidal solution, that should be the range, particle size range, that should be 10 angstrom to 1000 angstrom or 1 nanometer to 100 nanometer range. It's very important. If we call colloid solution, the particle size range will be 1 nanometer to 100 nanometer range. Okay. Suspension means nothing but that should be greater than 1000 angstrom. That should be 100 nanometer or greater than 100 nanometer. Okay. In true solution, pass through filter paper as well as animal membrane also. It should be passes through the filter paper as well as animal membrane. Okay. Colloid solution pass through filter paper but not through animal membrane. Colloid solution, that should be passes through the filter paper but not through the animal membrane. Suspension pass neither, so it does not pass filter paper and neither pass filter paper nor animal membrane. Okay. Now we consider true solution, that should be do not settle down. Always there must be uniform distribution between particles and the solution, so they never settle down. But colloid solution, that should be also never settle down, but you can see the particles. Okay, by using microscope or sometimes by your eyes you can see, but that should be rare. Okay. Suspension, that should be definitely settled. You always see by your eyes. Okay, the particles are may be settled. Okay, particles are definitely settled actually. Okay, true solution particles are indivisible. Okay, indivisible means we cannot see, they are completely miscible. Okay, colloid solution, they should be able to scatter light. Okay, scattering can be there. And suspension, that should be visible, you can see. Okay, true solution, that should be diffused quickly. Quickly they should be diffused. And colloidal solution, that should be diffused but with slow rate, that should be slowly. Okay, and suspension, that do not diffuse. Last and least, that should be true solution clear and transparent, colloidal solution translucent, and suspension, that should be opaque. Okay, now we have to consider colloid. So there should be two phases are there. One is dispersion phase, other is dispersion medium. In what medium the particles are given, or particles that should be added, this medium are termed as dispersion medium. And the particle that should be added, they are termed as dispersed phase. As for example, like adsorption, we get adsorbent and adsorbate. Where the adsorption take place, they are called adsorbent. Here, where the particles that should be dissolved and produce colloid or colloidal solution, they are termed as dispersion medium. Similarly, in adsorption, the particle that should be adsorbed, they are termed as adsorbate. Similarly, in colloidal solution, the particle that should be added are termed as dispersed phase. Okay. Okay. With respect to various type of dispersion medium and dispersed phase, we have to categorize many type of colloidal solution and their examples. Okay. First one, if dispersed phase solid and dispersion medium that also be solid, we can call the colloid as solid sol. Okay. And examples are colored glasses, gemstone, so on. Colored gases, gemstone, so on. Next one, dispersed phase solid but dispersion medium, that should be liquid. So solid, that should be added to liquid. That is types of solid means, types of colloid means sol. That should be called only sol, not solid sol. That should be known as only sol. Example are paints, cell fluids, and gold salts, proteins. Okay. Then dispersed phase, if solid and dispersion medium, that should be gas. That is solid, that should be added to gas. So that should be termed as aerosol. Okay, as for example, smoke and dust. Smoke, you know, many particles, many dust that should be in air. So in the case of, we can say they are aerosol, and air is a dispersion medium, that should be gaseous, and the particles that should be solid, they are termed as dispersed phase. Okay. Next one, if dispersed phase liquid and dispersion medium solid, we can type of the colloid that should be termed as gel. If liquid is added in the solid, that should be termed as gel. Examples, that should be cheese, butter, jellies, boot, polish, so on. Next one, dispersed phase, if liquid and dispersion medium, that should be liquid. So the type of the colloid is termed as emulsion. Example, that should be milk and hair cream. Milk and hair cream. There should be liquid mixture. Okay. Next one, dispersed phase liquid, and that should be added in the dispersion medium gas, that should be termed as liquid aerosol. Okay, that should be termed as not aerosol, that is called liquid aerosol. Okay. As for example, fog, mist, cloud, insecticide spray, so on. Then we termed as, if dispersed phase gas, dispersion medium solid, gas is added in the solid, so that should be termed as, I think there must be misconception. Okay, we rectified this. So pumice stone, foam, rubber, so on. That should be solid foam will be there. Okay, solid foam. Okay, we have to check out this thing. okay, in next slide, okay, in next class, okay. So that should be most probably solid form will be there, okay. And if dispersed phase gas, dispersion medium liquid, type of color that should be foam. So fourth, whipped cream, soap, suds, okay. Depending on dispersion medium, colors can be said as hydrosol, aquasol. If water as a dispersion medium, we can term as from water we can say hydrosol, from water we can say aquasol. As we know, that is when we say that is aqueous, HCl, aqueous something, means what? They are dissolved in water. Due to this water, we termed as aqueous. Okay, similar. If the dispersion medium is water, we can term as hydrosol or aquasol. If dispersion medium is alcohol, we can say that is alkosol. If the dispersion medium is benzene, that should be termed as benzosol. If dispersion medium is gaseous, that is we can term as aerosol. Okay. Now property hydrophilic colloids and hydrophobic colloids. That should be hydrophobic and that should be hydrophilic. Formation, hydrophilic colloids form easily by direct mixing of two phases. If two phases that should be mixed to each other, they should be produced hydrophilic colloids. There must be, the process is much easier to produce than the production of hydrophilic colloid. Hydrophilic colloid, special chemical methods that should be needed. Okay. Affinity, hydrophilic we can say, also we can say lyophilic, lyophobic. If the dispersion medium are water, we can say hydrophobic or hydrophilic, but if dispersion medium are not mentioned, we can say hydrophilic and hydrophobic. Okay. So lyophilic colloid, affinity toward dispersion medium is there, and lyophobic colloid, there should be no affinity towards the dispersion medium. Okay. Stability, that is lyophilic colloid, that is highly stable due to the layers of dispersion medium. Highly stable due to there should be lots of layers of dispersion medium, and lyophobic colloid, there must be less stable, are easily coagulate due to presence of charge. As there must be presence of charge is there, so there should be easily to coagulate. Okay. Reversibility, that is lyophilic colloids are reversible. Lyophobic colloid, that should be irreversible. Reversible means what? That is process can be gets to backward also. Okay, that is termed as reversible. And if the process having no chance to go backward and there only one chance, that is to go forward and forward direction, that should be termed as irreversible process. Okay, so lyophilic colloids are reversible and lyophobic colloids are irreversible. Electrophoresis, that is must be the movement of ions towards some electrode. Okay, as we know, in electrolytic cell, galvanic cell, there should be cation goes in particular electrode and anion goes particular electrode. Okay, right? There should be, we can measure galvanic cell, that is cation goes to cathode, anion goes to anode, so on. Okay. So we know that electrophoresis, that lyophilic colloids electrophoresis not show, and lyophobic colloids that should be definitely show electrophoresis because there should be charges there. Okay. Lyophilic colloids, that is coagulation, small amount of electrolyte have no effect. If we add a small amount of electrolyte, there should be no effect can be seen. But lyophobic colloid, small amount of electrolyte may coagulate the salt. Okay. Last and least, the topic that should be examples. Lyophilic colloids, that should be examples are sol of gum, gelatin, starch and rubber, etc. And lyophobic colloid, that should be salts of metal and their sulfide also. There should be macromolecular, multimolecular and associated colloids are there. Okay. First one, macromolecular colloids, dispersed phase particles are much larger. That's why we term as macro. Macro means larger. So there should be the dispersed phase particle that should be larger dimension. Okay, larger in size. Okay, example, starch, protein in water and synthetic rubber, polystyrene. Synthetic rubber and polystyrene. And multimolecular colloids, particle size in colloidal range. Colloidal range means 1 to 100 nanometer, not 1000. That should be 1 to 100 nanometer. Okay, not 1000. 1 to 100 nanometer, that should be sulfur sol. Now we consider associated colloid behave as normal strong electrolyte at low concentration. When concentration that should be low, it must be behave as strong electrolyte. But when high concentration, that should be act as colloid. Strong electrolyte, we know that should be dissociated into completely to its corresponding cations and anions. Okay, so they are termed as strong electrolyte. When concentration that should be low, they are behave as strong electrolyte, but when concentration that should be high, they behave as colloid. So, example of associated colloid, these colloid have both hydrophobic and hydrophilic part. Okay, they having both hydrophobic and hydrophilic part. Associated colloids are basically rare. Okay. Now we consider cap temperature, that is TK, minimum temperature above the formation of missile that should be take place. The minimum temperature, that is the lowest temperature. After that, the formation of missile that should be take place, and this particular temperature is called as cap temperature. Now we consider critical missile temperature, that should be called CMC, that is C for critical, M for missile, and C for again critical missile concentration. I think temperature not there, that should be critical missile concentration. Okay, not temperature, that should be not a temperature. Okay, that should be concentration. Okay, minimum concentration of the surfactant at which missile take place, that is the lowest concentration where the surfactant molecule, they should be engaged to each other and produce colloid. Okay, CMC of soap is value 10 to the power minus 4 to 10 to the power minus 3. Okay, lyophilic salt easily produced by shaking. If we dispersion medium and dispersed phase that should be taken, and that should be shaking, and by this way they easily to produce lyophilic salt. Okay, now lyophobic salt production, some chemical method is needed. First one, condensation and aggregation method. Condensation means that is units are some units that should be condensed, that must be they are engaged to each other to produce a other, that is bigger colloid material. Okay, so first one we go oxidation. Oxidation means removal of electron and increase of oxidation state, addition of oxygen and removal of hydrogen. They are termed as oxidation. Okay, here actually electron transfer can be there. So Br2, that is Br is a zero oxidation state to 2HBr, that is -1 and 0, right? And H2S2 sulfur is produced. Sulfur -2 to sulfur 0. Okay, so there should be oxidation method can be there. And SO2 plus 2H2S, we get 3S sol and plus 2H2. Actually there should be, we produce sulfur sol by oxidation method. Okay, there should simply, that is oxidation can be take place, that is Br2 plus H2S, that is 2HBr. There should be Br0 to Br-1. Reduction can be there, that is oxidation state that should decreases. But H2S, that is sulfur -2 to sulfur, that is 0 oxidation state. Here oxidations take place. Here oxidations take place. Okay, now we consider reduction. Reduction means what? Addition of hydrogen, removal of oxygen, gain of electron, oxidation number decreases. Okay, there must be 4 possibility. Okay, there should be 2AuCl3 plus 3SnCl2 ultimately produce 2Au sol, gold sol or purple of gaseous plus 3SnCl4. As you know, there should be -3 and that should be +3. Au is exhibit +3 and from this we get 0. So oxidation number that should be decreases oxidation number. Okay, so there should be definitely reduction occur of Au. Okay, reduction of Au that should be take place. That's why we get Au sol. So that there must be, why can we use the oxidation process and reduction process? As we know, we produce sulfur sol by oxidizing the sulfur. Okay, the oxidation number of sulfur that should be increases, and that's why we get sulfur sol. So the overall process is termed as oxidation. And next one, Au sol, that is gold sol. Gold sol we get by reducing the AuCl3, means we get Au sol by reducing or by decreasing oxidation state. So by this way we get gold sol. So the overall process is called reduction process. Hydrolysis means there should be water that should hydrolyze something. How we can justify? That is FeCl3 ferric chloride plus 3H2O, that should produce FeOH whole 3. So all Cl3 are replaced by OH whole 3. So there should be hydrolysis can be there. Okay, and all H2O that should be give up their 3 hydrogen H plus, and that should be combined with 3 Cl minus to produce 3 HCl. So overall we get the hydrolysis process. So that's why the process is hydrolysis. Last one, double decomposition. That is one atom or one thing that should be replaced to other, and other that should be replaced to first one. Okay, like for example, H2AC. There, for example, oxygen O3 that should be replaced by sulfur 3, and sulfur is replaced by oxygen. So we can term as that is sulfur that should be replaced by oxygen. Okay, and oxygen that should be replaced by sulfur. Okay, so we can say this is called double decomposition. Okay. Now we call that is properties. Colligative properties are very small. Their colligative properties are very small because they engage to produce large interior. Okay, they are termed as colloid. So their overall particles that should be decreases. So their colligative properties that should be decreases. Okay. The color of the colloidal particles also depends on the manner in which the observer receives light, because it should be scattered the light. So by this way we can see the color of the colloid solution that should be depends upon which type of light that should be scattered, and the observer that should be observed the light receives. Okay, colloids scatter light obviously, and that should be show Tyndall effect. Okay, now we go Brownian motion, that should be called zigzag motion. Smaller the size of particle, lesser the viscosity. The viscosity that is attached with some layer that should be decreases, and faster will be the motion. Okay, the diameter of the dispersed particles is not much smaller than the wavelength of the light that should be used. Diameter of dispersed particle is not much smaller, that is not so smaller than wavelength of light that should be used. The refractive indices of the dispersed phase and dispersion medium that should be differ greatly in magnitude. There are refractive indices of both of dispersed phase and dispersion medium that should be differ in greatly in magnitude. Okay, and the nature of the charge is the same on all the particles in given colloidal solution, on maybe either positive, maybe negative. If you consider some portion the colloid is positive, so always remember whole of the colloid solution that should be positive. If some portion that should be negative, means whole of the colloidal solution that should be negative. Okay, the nature of the charge is the same on all the particles in a given colloidal solution, and maybe either positive or negative. Last one, potential difference across this electric double layer is called zeta potential. It's nothing but there should be electrical double layer produced when the colloid formation takes place, and across this there should be potential difference can be generated, and that termed as zeta potential or electrokinetic potential. Two layer develop, one that should be fixed and other that should be diffused, and there should be potential electrical double layer that should be formed. Okay. Okay. There should be two layers, there should be potential difference can be generated, that should be called zeta potential or electrokinetic potential. Okay. Electrophoresis, that is towards form, as we know, some of the cases the electrolytic cell or galvanic cell, there should be some that is cathode, suppose anode, there should be go anion, Cl minus go this side, Na plus go this side, and these phenomena, based on these phenomena, we get the concept electrophoresis. Okay, electrophoresis. So electrophoresis can be occur, and coagulation or flocculation that should occur. Okay. Positively charged colloids, that is metal hydroxide, basic dyes like methyl blue solution, protein in acidic medium, oxide like TiO2 solution, all are behave as positive charged colloids. They are due to positive anions, due to positive cations, or due to some positive characteristics can be shown in the solution. Maybe excess of cations are present. Okay. So metal hydroxide, basic dyes like methylene blue solution, protein in acidic medium, oxide like TiO2 solution. In the solution, maybe the positive cations are present in excess. That's why the overall solution that should be positively charged. Okay. So negatively charged molecules, when the excess of anions that should be present, that's why negatively charged. Okay. So metals like copper, Ag, Au, etc., metal sulfide, acid dyes. Remember that is basic dyes are categorized in positively charged colloids. So acidic dyes that should be definitely opposite, that is negatively charged colloids. Okay. There should be no confusion. Basic dyes, if they goes to positive charged colloids, so obviously acidic dyes that should be goes to opposite, that is negative charged colloids. Okay. Salts of starch, gum, gelatin, clay, charcoal. Now always remember coagulating power that should be inversely proportional to flocculating value. Coagulating power proportional to 1 by flocculating value. Now consider Hardy-Salch rule. That is, get out the valency of the oppositely charged ions when their valency that should be higher. Means charge higher, more will be the coagulating power. That is coagulating power that should be proportional to charge. They always precipitate. Okay. More will be the coagulative power. So As2O3 salt, the order that should be Sn4 plus is more, then aluminum 3 plus, then calcium 2 plus, then sodium plus. So there should be 4 charge, there should be 3 charge, there should be 2 charge, there should be 1 charge. So when the charge that should be decreases, so coagulative power also decreases. Okay. Similarly, for TiO2 salt, the order is, that is ApCN whole 6 4 minus, then PO4 3 minus, then SO4 2 minus, then last one Cl minus. Okay, negative charge decreases, and by this way coagulative power also decreases. Now we consider emulsion, water emulsion, and now up to this we consider only colloidal solution, but now we have to consider emulsion. Emulsion that should be, as per emulsion, that should be the particles are larger in range than colloidal solution, and they always having the tendency to settle down, and they are visible in nature, and they are visible in nature. Okay. Okay. Emulsion basically, we example that is most important. 2 examples are there. One is oil in water and water in oil. Okay. We know that is water and oil are not miscible anytime. Are not miscible. Never miscible. So when oil is put in water, water is a dispersion medium, as for example milk. When you see milk closely, that is must be not a artificial, or we have to consider best example is cow's milk. Okay. So when you see, you always notice that in the liquid solution there should be some oily things are there, and they are not completely miscible. Okay. This is termed as milk is a best example of oil in water. Water is a dispersion medium. But when water in oil, example is cod liver oil. Cod liver oil is used for medicine, for eye treatment. Okay. Or vitamin A source. Okay. Now, emulsifying agent or emulsifiers, we can say emulsifying agent as well as emulsifier are the substances that should be added in small quantity to stabilize the emulsion of fairly high concentration. So for stability, emulsifying agent and emulsifier that should be added. Okay. Next one, de-emulsification, that should be opposite, that is the separation of emulsion into its constituent liquid is called demulsification. So emulsifying agent and demulsification, that should be opposite, because demulsification focused on separation of an emulsion into its corresponding constituent liquids. Okay. If we consider gels, gels may be the elastic gel, that is example gelatin, agar-agar, starch. Okay. And gels can be classified as non-elastic gel, that should be silica, alumina and ferric oxide. Silica, alumina and ferric oxide. Okay.